Okay, question 3 asks us about which of the alkyl halides react fastest in E2 elimination. Okay, so E2 is different than SN2, and with E2, tertiary alkyl halides react fastest, followed by secondary, followed by primary, which reacts slowest. And this trend is the same for E2 and E1. Okay, so what we have to do is classify our alkyl halides. A is tertiary because this carbon containing the bromine is connected to 3 other carbons. B is secondary, and C is primary. So based on what we wrote here, saying that tertiary is the most stable and it reacts fastest. Okay, question 4 asks us about acidity of hydrocarbons. Okay, so what we have to look at is, okay, so here we have to know our pKa trends for these hydrocarbons. And if we look at A, this carbon that the hydrogen is attached to is sp2 hybridized. For B, the carbon that these hydrogen are attached to is sp3 hybridized. And for C, the carbon that this hydrogen is attached to is sp hybridized. And the trend we have to follow is that sp hybridized carbon, or CHs, are most acidic. Okay, then we go sp2 and sp3, where sp3 is the least acidic. Okay, and that has to do with conjugate base stability. So for the sp hybridized CH, the conjugate base would have a negative charge on the sp hybridized alkyne, and having that negative charge on an orbital with more s character leads to a more stable negative charge because the s orbital lies closer to the nucleus. So based on that, we can pick C as the most acidic hydrogen.